Hello everyone, I am back with another question. The question is from the chapter Gravitation, class ninth. The question says the density of planet 1. The density of planet 1 is thrice that of planet 2. If I let the density of planet 1 be rho 1 and density of planet 2 be rho 2, then rho 1 is thrice, that is 3 times of rho 2. This is the first information given in the question. Okay. Now the second information is the acceleration due to gravity at the surface of planet 1 is 1/9 of that of planet 2. So let the acceleration due to gravity of planet 1 be g1 and of planet 2 is g2. So g1 is 1 by 9 of g2, that is g2 by 9. G1 is g2 by 9. This is the second hidden information, not hidden, given information. Now if the radius of the planet 2 is r, now if the radius of planet 2 is r, then the radius of planet 1, then we have to find the radius of planet 1 in terms of r. No, all the options are given in terms of r. We have to find the radius of the first planet. If the radius of second planet is r, then we have to find the radius of first planet. A bit of mathematics is also required in this question. So what we can do here is we can do. So first we will calculate the mass, because mass is required to solve these questions. So mass of planet 1, m1. What is mass? First of all, what is mass? Mass is mass is density times volume. Density times volume is mass. So mass of 1 is density of 1 times volume of 1. And you should know the volume, you should know to calculate the volume of spheres, since planets are in the form of a sphere, and the volume of a sphere is volume of a sphere. Volume of a sphere is equal to 4 by 3 pi r cube. So for answering this question, we need to calculate the volume. That is the very first step. We need to calculate the volume of both the planets. So first I will calculate the volume of planet 1. So volume of planet 1 is going to be 4 by 3 pi r1 cube. Volume of planet 2 is going to be 4 by 3 pi r2. R2 is r only, so r cube. Okay, no problem. Now instead to write this volume of 1, I can write rho 1. So if you look carefully, what is this rho 1? Rho 1 in terms of rho 2 is 3 rho 2. So I can write it as 3 rho 2 times volume of planet 1. Volume of planet 1 is 4 by 3 pi r1 cube. 4 by 3 pi r1 cube. Cancelling out this 3, we are left with m1 is equal to what? M1 is equal to 4 rho 2 pi r1 cube. Okay. Similarly, if I calculate m2, so m2 will come out to be rho 2 times v2. What is rho 2? What is the rho 2? What is the density of second planet? We have taken it as rho 2 only. So rho 2 times volume of 2 is this. Volume of 2 is so volume the second planet is this much, 4 by 3 pi. Volume of second planet is this much, 4 by 3 pi r cube. So I will write this 4 by 3 pi r cube. This will become 4 by 3 rho 2 pi r cube. Now these two are important. this m1 and this m2. Sorry, this m1 and this m2. Let me highlight this m1 and this m2. Yeah, so let me take a page. Now what we will do is, we have calculated the m1 and m2s respectively. Now I need to calculate the, I have the given relation that g1 is g2 by 9. g1 is g2 by 9. This relation I have. So from here I can write 9g1 is equal to g2. Now let me calculate g1 and g2 separately. So the formula for calculating g, the acceleration due to gravity, I think you have studied. The formula for calculating acceleration due to gravity is given by g is equal to capital G m by r square, where m is the mass of the planet and r square is the radius of the planet and g is the acceleration due to gravity. So g1 is going to be capital G. Okay, then m1, what is m1? m1 by r1 whole square, g1. So g into m1, just we have calculated m1 is going to be 4 rho 2 pi r1 whole cube. 4 rho 2 pi r1 whole cube. 4 rho 2 pi r1 4 rho 2 pi r1 cube, sorry, not whole cube, cube. This is by r1 whole square. If I cancel out this with this, no problem. So g1 comes to be 4g rho 2 pi r1. This is the value of g1 which I have calculated. Now for g2, the same formula where gm2 by r square, since r2 is r only. So g is g. What is m2? m2 is 4 by 3. m2 is 4 by 3 rho 2 pi r cube. 4 by 3 g 4 by 3 rho 2 pi r cube by r square. This r square will cancel this. Now we are left with g2 is equal to 4 by 3 times g rho 2 pi r. This is the value of acceleration due to gravity of the second planet. Now I have the relation 9g1 is equal to g2. So 9 times of g1 is what? This much. 4g rho 2 pi r1. This much is equal to g2, that is 4 by 3 g rho 2 pi r. So if I cancel out from this 4g rho 2 pi I have cancelled out. Now I have r1 is equal to r2 by 3. 9 r1 is r2 by 3. R2 or r only. So r1 is going to be r by 9 times 3 is 27. So the radius of first planet is 1 by 27 of radius of the second planet. So B is the correct answer to this question. Thank you.